You love maths. You're good at physics. And everyone keeps asking, so are you going to do engineering? And you're not sure how to answer because you're not even sure what the difference is. Today, I'm going to break it down clearly. Pure maths, physics, combined degrees, and engineering. What each one actually leads to and how to figure out which fits you. A pure mathematics degree is exactly what it sounds like. The deepest, most abstract training in mathematical thinking. You study things like analysis, algebra, topology, number theory. It's less about applying formulas and more about proving that the formulas work and why. The misconception is that pure maths only leads to academia. That's not true. A maths degree is one of the most versatile qualifications you can have. Quant finance, the people designing algorithms at hedge funds. They love maths graduates. AI research, data science, cryptography, consulting. The mathematical rigor you develop is exactly what these fields want. One important thing, the more abstract your degree, the more you'll need to complement it with coding and applied skills, either alongside your studies or after. But the ceiling is very high. Physics sits between pure maths and engineering. You're still building deep theoretical foundations. Quantum mechanics, electrodynamics, thermodynamics, but you're applying them to understand how the physical world actually works. Physics graduates are incredibly sought after in industry precisely because they can model complex systems, think quantitatively, and adapt to problems they've never seen before. You'll find them in aerospace, semiconductors, energy, finance, and increasingly in AI research. And if research is your thing, a physics PhD, especially from a place like EPFL, ETH Zurich, or Oxford, is one of the most respected qualifications in the world. It opens doors in both academia and industry. Some of the most interesting programs right now are combined degrees. And for students who are strong across multiple subjects, they can be the best of both worlds. At École Polytechnique, for example, the Bachelor of Science lets you combine mathematics with either physics, computer science, or economics. At Cambridge, Natural Sciences lets you start with physics, chemistry, and maths before specializing. At TU Delft, you can literally do a double bachelor in applied mathematics and applied physics and come out with 2 diplomas. These programs keep your options open the longest. You're not committing to one narrow path at 17 or 18. And for someone who genuinely loves both maths and physics, they're often the right answer. Now, engineering. This is where people get confused because engineering is not one thing. It's a whole family of very different disciplines. And the distinction matters. At the broadest level, engineering is about applying scientific principles to design, build, and solve real-world problems. It's more applied than pure maths or physics. You're learning how to make things work, not just understanding why they work. That's not a lesser path, like it's a different one. And for a lot of students, it's the right one. But before we go further, let's talk about the different types of engineering because they are genuinely very different from each other. Mechanical engineering is about physical systems, machines, structures, thermal systems, fluid dynamics. It's broad and graduates work in everything from aerospace to automotive to energy. Electrical and electronic engineering covers circuits, signals, power systems, and increasingly feeds into robotics, AI hardware, and telecommunications. computer science and software engineering, more maths heavy than people think, especially at top universities. Strong overlap with applied maths at research level. Aerospace engineering is essentially mechanical engineering focused on aircraft and spacecraft, highly specialized, competitive, and for a specific type of passion. Chemical and materials engineering, that is a bit more niche, but incredibly important in energy, pharmaceuticals, and advanced manufacturing. And then there are programs like engineering science at Oxford or the Grande École programs in France, generalist engineering that teaches the fundamentals of all of these before you specialize at master's level. These are often the most intellectually demanding and the most flexible. Here's my honest framework. If you love the theory, the proofs, the elegance, the why, maths or physics is probably your direction. If you want to build things, solve tangible problems, and move into industry more directly, engineering. And if you're not ready to choose, a combined degree or a broad generalist program is the smartest option. One thing I want to be clear about, none of these is a dead end. A physics PhD can go into finance. A maths graduate can become an engineer. An engineer can do a research master's. The path matters less than the quality of the institution and the depth of your training. If you want help figuring out which direction fits you and which programs are realistic given your profile, that's exactly what we do at SOS.